Hello everyone, this is Matt Tanner, and with today's video we're going to be looking at the anatomy or the structure of an electromagnetic wave, and then also looking at the electromagnetic spectrum as a whole. So let's get started. First up, let's look at the anatomy, or like I said, the structure of a wave. So we'll draw a quick wave in here, and sorry for the rough drawing, but we want to label the different parts. So if we're looking at the parts of a wave, we have a crest at the top of the wave, and we have a trough at the bottom of the wave, and then there's going to be a few more things. So the top of the wave is the crest, the bottom is the trough. If you wanted to imagine a line running halfway between the crest and the trough, and then you measured the distance from the midpoint up or from the midpoint down, it would be the exact same distance. This is the amplitude of the wave. And then finally, the distance from one crest to another, or from one trough to another, it would be the same distance, is our wavelength. So we have crest, trough, amplitude, and wavelength here. And the wavelength is something that's really interesting to look at, because if we're drawing a wave that has a very large wavelength, as this photon, or this would be a traveling photon, as this photon comes towards you at the speed of light, you're not going to have very many waves hitting you, at least not comparatively. If instead we drew an electromagnetic wave here with a very short wavelength, and again have that photon, as that photon is coming towards you, you're going to be getting hit with a lot more waves in the same amount of time. So this tells us two things. The shorter the wavelength, so the shorter the wavelength, the higher the frequency of the wave, and therefore the higher the energy of the wave. When we have a larger wavelength down below, we have decreased frequency and decreased energy. So let's look at how the wavelengths change across that electromagnetic spectrum. If we were drawing it starting with low energy on the left, going up to high energy waves on the right, it might look something like this. So again, it's a rough drawing, but you can see as we go to increasing energy, the wavelengths are getting smaller, and with that decreasing energy, the wavelengths are getting larger. And the lowest energy electromagnetic waves means they have the largest wavelength are radio waves. The highest energy waves with the shortest wavelengths are gamma rays. And as we work our way up, we would have radio waves, microwaves, infrared, visible light, which we're going to come back to in just a second, ultraviolet, X-ray, and then finally gamma rays is the highest energy. So again, this is the going from left to right here is increasing energy. And if we focus on that visible light, which is between infrared and ultraviolet, and we move out on that, red is the lowest energy, then orange, followed by yellow, then we get green light, blue, indigo, and then finally violet. I know it's hard to see the difference in color there. And if you get a mix of the low wavelengths or all of these colors, you end up with white light. So when we see white light, it is a mix of the rainbow of colors, but you can also emulate white light with just a mix of low, medium, and higher energy wavelengths, which is why an LED light can take red, green, and blue and come to what looks like a white light as well. So that's going to be our notes for the anatomy of a wave and an electromagnetic spectrum. See you next time.